Okay, we're going to look at the steps for sketching cubic graphs. If you learn these steps, it's going to turn into lots of marks in this section. This is sometimes a standard thing where you can pick up lots of marks. Here's the form of a cubic equation: ax cubed plus bx squared plus cx plus d. Now all of these can be zero, but if it's going to be a cubic equation, it's got to have x cubed in it, so a has to be something. If a is bigger than 0, if it's a positive number, then this is the shape. It turns, and then it turns, and then it goes up. But if it's negative, it turns, and then it goes down the other way. That's the basic shape. First, figure out the shape, just like you would with a parabola. And then the same thing. Make x equals 0 to find the y-intercept. So if those are all 0, then the y-intercept is just d, just like a line or a parabola. But x-intercepts, you have to make y equals 0 and then solve this. Now sometimes they put it in the form of brackets and you can just see the answers. These are the places. This is the x-axis here. Here's an example. It's like A, B, and C are the x-intercepts. There's a thing called the factor theorem, and I'll have a video and a slide where we just look how we can use the factor theorem to figure out what these x-intercepts are. Then stationary points. Now if you want to find stationary or turning points, that's right where D is and E is here. All you do is take the derivative of this thing and make it equal 0 and solve for x. And then you'll get those x values of the turning points. And then put those x values into f and you'll get the y value. That's it. You do the same thing every time. And the last thing is the point of inflection. You make the second derivative, you take the derivative of the derivative and make it equal to 0. And then you'll find the point where it changes concavity. You see right about here where it turns from concave down to concave up? That'll be the x value of the point of inflection. And then you just put it back into f, the original one. You'll get the y coordinate of the point of inflection. Those 5 things are always the same for a cubic graph. Let's take a look at an example. Say sometimes they give you the equation in both forms. Well, there it is. There it is. So first, what's the shape? Well, that's positive 1 there. So the shape must be like this. Okay, I've got the shape. In fact, we're doing this graph right here. So that's how you'd get the shape of the graph. And you get a mark just for that. If you let x equal 0, that's nothing. Y equals minus 4. There's your y-intercept. At 0 and minus 4 at f there. Okay, now how are we going to get the x-intercepts? Well, they've been kind to us here because they've given us brackets. And we can just say 2, minus 2, and minus 1 and 0. There's the x-intercepts. And it's A, B, and C. Because I got GeoGebra to graph this thing so we can look at it. That's it. Now here's the big thing. Find the turning points, and later on it's finding a maximum or minimum. We always do the same thing. We take the derivative, so we go 3x squared plus 2x minus 4. There's the derivative. We make it equal 0. Now here, you're going to have trouble factoring this because it doesn't factor. So just put it into the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a, and you just put it in the quadratic formula. I get 0.87. And then I put that back into the original equation. Just put a bracket, put 0.87 right in there. And what will you get? You'll get negative 6.06 out. There is that turning point right down here at 0.867 there, 0.87. And then you put the minus 1, you get negative 1.535. I round it off to negative 1.54. Put it back in the original function, put it in your calculator, you get 0.88. That's D. The D and E are the turning points. And the last thing is the point of inflection. You take the derivative of this, 3x squared plus 2x, so it's 6x plus 2. You make it equal 0. And you solve. Subtract 2, divide by 6. At x equals minus a third, that's the point where it changes concavity. It's called a point of inflection. I didn't find the point. If I take minus a third and I put it back into the original function here, I'd get the y coordinate if they ask for it. Okay, well there you go. That's how it